So now we're going to talk about the converse of the Pythagorean theorem, which means we're going to go backwards. We're going to start with a right triangle, or a triangle, I should say, and we're going to prove if that triangle is a right triangle or if it is not a right triangle. And we're going to use the Pythagorean theorem to help us out. So you will have to write these down in your notes. The Pythagorean theorem is a squared plus b squared equals c squared, where sides a and b are the legs of a right triangle, and C is the hypotenuse of a right triangle. What does C stand for in this equation? C is always, capital right there, always the hypotenuse of a right triangle. The hypotenuse is always the longest side. So let's look at what we're given. So here we have the Pythagorean theorem, a squared plus b squared equals c squared. We can ignore all of this stuff that was over here. So we need to justify if each of these triangles is a right triangle or not. Add our justifications below. So our justification is going to be our work. Here's how we show our work. I'm going to go with this first triangle right here on the left. The longest side of this triangle is 10. So this is the presumed right angle. 10 is my hypotenuse. So I know 10 is going to be my C value. So I'm going to do a squared plus b squared equals c squared. And now I'm just going to simplify all the way down, and if the left side equals the right side, it is a right triangle. If the left side does not equal the right side, it is not a right triangle. So here we go. That's after squaring them. Now I'm going to combine my terms on the left. 36 plus 64 is 100, and 100 does equal 100, check, so yes, that is in fact a right triangle. Now my second triangle. 6 is the longest of the three sides. Let's go with blue. So that means 6 is my hypotenuse. 4 squared is 16 equals, oh, that's not 25 squared. It's just 25. There we go. Now I'm going to combine my terms on the left. I get 41, which does not equal 36. See how when I simplified the left, it does not equal the right? So no, this one is not a right triangle, and here is my justification why. So next, a squared plus b squared equals c squared. The most important number is your hypotenuse, is your c squared. And I know that 6.5 is my hypotenuse because that's the largest of the three numbers. So I square this, get 6.25 plus 36, and let's get 6.5, square that. That is 42.25. And when I add my terms on the left, these two, I combine them, I get 42.25, which does in fact equal 42.25. So yes, that is a right triangle. And last, leg squared plus leg squared equals the hypotenuse squared. So when I square these, I get 16 plus 49 should equal 64. Combine my terms on the left here. 65, which does not equal 64. Left does not equal right, so no, that is not a right triangle. So which of these lengths represent side lengths of a right triangle? We only want to know which one represents a right triangle. So I have 3 lengths here. If it helps, which usually it does, we're going to draw a triangle. And I know that 15 is my largest of the 3 numbers, so that's going to be my hypotenuse. The other 2 are my legs. So I'm going to, well, Pythagorean theorem, we should always write this down. I substituted my values into the Pythagorean theorem, and now I need to simplify. 81 plus 144 equals 225. So I need to add my terms on the left. 225 does in fact equal 225. So yes, this is a right triangle. Let's do the second one now. That is a poor right triangle. It's a sort of better one. We'll pretend it's good. 20 is my longest side. Ten squared is 100. Plus 225 should equal 400. 325, when I combine my terms on the left, does not equal 400, so that is not a right triangle. .5, 12, and 12.5, because this is my largest number, so this is going to be my hypotenuse in this case. After squaring all of these, now I add my numbers on the left. I get 156.25, which does in fact equal 156.25. Check. So these two are my right triangles, and there's my explanation or my proof by using the Pythagorean theorem. Here we go again. Okay. This looks like it's going to be my right angle, so that means that's going to be my hypotenuse. Here's my justification for proving if this is a right triangle. So there are my leg lengths right there. Square root of 15 is A, square root of 21 is B, equals 6 squared. We want square roots to be in here. If you type in your calculator the square root of 15 squared, right, we should know that square rooting and squaring are inverses of each other, which means they completely cancel out. So even if you plug these into your calculator, you're going to see that the squaring and the square root cancel out, leaving you with your base. So the square root of 15 squared is just 15. The square root of 21 squared is 21. 6 squared is 36. I combine my terms on the left. 36 does equal 36. There's my proof that yes, this is a right triangle. Now let's do the same thing down here. I have the square root of 45 squared, because that is a leg, plus the square root of 65 squared, that is the other leg, and 10 is going to be my hypotenuse, because this looks like that would be the right angle if this is a right triangle, which means 10 is opposite of that. Square root of 45 squared is 45. Square root of 65 squared is 65. 10 squared is 100. 45 plus 65 gives me 110, which does not equal 100. So no, this is not a right triangle. So that would not be a right angle, and that is proof as to why.